Alright, now that we've done a bit of work talking about the basic operations of an array list, as well as talking about how array lists work under the hood, we can spend some time actually writing methods that operate over array lists. So, one of the simplest things that we can do is write a method that filters things out. So, let's design the remove negatives method that receives a list of integers and returns a list of integers such that all of the integers from the original list are removed. Okay? So there's a bit of a design question here. So one of those design questions, well actually let's first talk about tests before we even consider design implementations, okay? So let's write some tests. The question is, how do we test an array list? Well, the way that we tested arrays was with assert array equals. Fortunately, array lists are much simpler. We can just use the assert equals method, and if we give it two lists, it will compare them for value equality, which is very nice. Okay, so let's say, but there's sort of another issue here. How do we say that how do we say we want to expect a certain list? Well, one solution might be to say that we have a list that we're going to test, and then we can just add elements to that list. Like let's say add 42, act list.add -1, act list.add -4, act list.add 83, and then the expected list is another list where we do expected list.add 42, expected list.add 83, and then we say we expect the expected list, and then we're going to call the remove negatives method on the act list array list. Okay? Now, I mean, that works, but the problem is this is really just clunky, and I'm sure everyone watching agrees. So there's something else we can do. Instead of doing all of this, we can actually just use something called list.of. Okay? So list.of, very importantly, creates an immutable list. What that means is that if we try to do something, so let's go back to our list example here. So if we create a mutable list, we can do that by doing list.of, and then we pass it some values. Like this, okay? So if we do that, now L is defined to be an immutable list. So if we try to change this list by doing this, then we're going to get something called an unsupported operation exception. Because when we create an immutable list, what this is doing is saying, yeah, you can't modify this. You can query it, you can look into it, but you can't modify it. You can't add anything, you can't remove anything, you can't insert anything. Okay? You can't set anything. The only thing you can do is just query into the list. And sometimes that's what you want. Okay? Other times you might want to just say, okay, well, I want to create a mutable list, but I don't want to have to, type out the list.add, list.add, list.add. Well, you can do a little trick here by first creating an array list, and then inside of its parentheses, pass list.of. Okay? And then what this will do is it will convert this immutable list into a mutable list. And then we can do l.add just fine. Okay? So this now should contain 42, -1s, -78, 83, 42. Okay? Good. So let's replicate this idea by passing list.of, and because list.of resolves to something, we can just pass that to a method. So let's pass 42, -1, -4, 83, and then the expected list will also say is a list, or is an immutable list. Okay? Now, I think if we're writing tests, then we should probably test multiple things. We should test a list that contains only negative numbers, which would of course then resolve to the empty list. We should test a list of positive numbers, so which returns the original list. We should then also test the empty list, right? So remember, when you're writing tests, they should always be comprehensive. Okay? Now, of course, right now, all of our tests are going to be null because we haven't done anything. Okay? So here's a design question for you. There's actually a separate way we can define this method. So I'm going to do this in this file because I don't want to interfere with our implementation of this. So one thing that we haven't really talked about is this void keyword. I mean, we've said that it means that the method doesn't resolve to anything or doesn't return anything, but what are the implications of doing that? Well, just like how we can mutate arrays in methods because we pass them by pseudo-reference, we can also mutate ArrayLists. So, what do I mean by that? Let's say we have a method called mutate, and it receives a list. I don't know why I typed that. And let's say that it just adds the element for the list 42. Okay? And let's say that we create a list out here that has the values 42, -1, -4, 83. Now, if we call mutate on L, because we pass this by pseudo-reference, what's going to happen is this ls is going to mutate, or this method is going to mutate L. So instead of changing a copy of L, we're actually just going to change L in and of itself. See? So this is, kind of a bad way to program. And the reason why is because when you're designing methods, you usually don't want to mutate the state of an object. Because when we call this method, we don't really know what it's going to do or how it's going to mutate the list. Okay? Now there are some instances where mutation has to occur, like if the problem calls for it. And as we'll see when we talk about mutation later in the class, there's definitely uses for it. But for now, when we create a method, it's usually a good idea to not mutate the existing list. And what's a little bit worse about this is if we try to do something like this, where we pass an immutable list to something that expects a mutable list, then we're going to get this unsupported operation exception. Okay? And what's triply worse about this, I think I said two things. Another thing that's worse about this is that you really can't test void methods. I mean, there is a way to test how a void method changes something, but that's really not what we should do here. So what's the alternative? The alternative is to, instead of mutating the original list, so for example, writing a method that removes all the negative numbers from L, which would mean that if we called remove negatives on L, then printing L, or using L from that point on, would have 42 and 83. There's actually a better solution to this. The better solution is to instead create a method that will create a new array list that has the properties that we desire. So what is the property that we desire? The property that we desire is a list without the negatives. So what we can do is let's first create a new list. Okay? And then we're going to return the new list. So remember, this is the thing that I sort of talked about, where we create something, we do some stuff, and then we return it. Okay? So what we're going to do is we're going to traverse over this list, and then we're going to add all of the positive numbers to this list and just ignore the negatives, right? If we create a new list where we only have positive numbers, then that's the same thing as removing the negatives, okay? And that makes it very easy to test. And remember, even if we pass an immutable list here, we're not going to mutate the given list. We're going to create a new list that has the property that we care about. Okay? Now, how do we traverse over a list? Well, like I showed you in the video before last, we can do something like this. So for int I equals 0, I is less than ls.size, I plus plus. And then we can just say if the ith element of this list is a positive number, which is greater than or equal to 0, then we're going to add it into our new list. So we'll say if ls.getI is greater than or equal to 0, then we're going to do new list.add ls.getI. Okay? Now I actually just realized that there is an edge case that I'm not testing here. So I should probably add 0 to one of these lists. Okay? Because in this list, 0 should not be removed out because 0 is not negative. Okay? So now let's rerun our test, and all tests pass. Okay? But just like with arrays, remember the enhanced for loop? We don't need to say for int I equals 0, I is less than ls.size, I plus plus. We can get around that and make this much cleaner by just saying for every n that's in our list, then we want to say if that n is greater than or equal to 0, add it to the list, add it to our new list. Okay? This is much cleaner. And thankfully, because the I that we were using only references an index, we can do something like this. Sometimes you need the index, right? Some problems require that you know the index that you're going to use. And that just, again, that just depends on the problem. Okay? So sometimes you're able to just use an enhanced for loop to traverse over your data, and sometimes you can't. Okay? So in this video, we talked about removing negatives, we talked about how to test methods that return array lists, we talked about passing array lists to methods, we also talked about this concept of immutability. Okay? Now, again, this would work if we did something like, or this would still work even if we did new array lists. If we converted these to mutable array lists, this would still work. Okay? Because again, this would be comparing the contents of these lists and not the, or rather the contents of the returned list rather than what the lists are themselves. Okay? And we can also do something like new array list of this, so we can convert this into a mutable list, and even though this returns an immutable list, it doesn't matter. Okay? Now, really, this is a bit disingenuous, and but it doesn't really matter because, again, all we care about is that the two methods, or rather, that the method, that the remove negatives method returns correct values that should be in this expected list.